Hello, welcome to another video. Where what are we doing? We're looking at the Z machine interpreter. I don't actually need these. Um, the Z machine interpreter that I am working on in Odin. So, uh, yeah, it's basically implementing a Z machine, which is a virtual machine that was devised in 1979 to play Zork, a text adventure game. And I'm going to be doing it all in Odin, a new language to me. And there is a nice, this one here, specs that I'll open up. And this episode, we're going to be looking at the text. So just to see where we have got to, I might just close that and then Odin run dots and ROMs that. Um, so it's basically getting up to the same point that we were last time. The put prop. I did do some kind of refactoring, I guess you could say. So I moved the kind of execution loop out of machine into execution, so it's kind of all in one place and not kind of making machine a bit too much stuff. And I also split out the jumps, like I mentioned I would last time. So now the jump instruction should be a lot easier, except for the jump instruction, which weirdly doesn't take a branch, it takes a operand. And what else have I done? I've made kind of an object which will basically do object dump. We'll see that soon. Opcodes I took out of instructions, so again they're all in one place, and not that one. So they're all in one place, and the ops that are needed are all in one place, and whether they need a branch store or Z string, all in one place. So basically, the idea is I only have to edit one file when I add a new opcode to get basically the instruction paths. But I will need to also edit the instruction dump, which takes switches over all the opcodes here. So I'll also need to put something here, which most of the time will just be in this first section where it just dumps all the operands that it has, and the rest kind of just does the right thing when it needs to. Um, Except for jump, which does things a bit differently, so it has to do a return there. So I guess where are we at? I'll do a make just to get where it's kind of unimplemented. So it's in Z string dump. So I kind of started, well, I kind of mentioned it the other episode yesterday that there's a bit of an unusual encoding for the Z string. So they're not actually strings as in 1 byte is 1 character. It's actually 2 bytes is 3 characters. And then you have like a stop bit type thing. And they say it's similar to the 5-bit Baudot code. I think that's how you pronounce that. Could be wrong. And that was used by like teletypes. If anyone remembers teletypes, I could be showing my age here. So I've got the very basics of what a Z string will be. Basically, it will have a struct and it will have a string builder. So it'll, like, build the string as we go along. And I suppose I need a length here so it knows how much to say that it has been used up. But they'll kind of come later when we pass the um, instructions that take a Z string at the end, because that's a variable length format. Whereas the format I'm doing will be an object. Come on. Still have that weird thing. Not Odin. Object. Try that again. So I've got an object that basically takes the object number that it's looking for, make sure that it's not equal to 0. And I suppose I could actually do tables is what I want, object table. I could also do like make sure that it's not over 255, which it is a U16. So if it's 1 to 3, then it has to be 255. Otherwise, it's as much as you can fit in a U16. So I might do that. If header dot version is less than equal to 3, do assert objects objects number less than pick up 6. Yeah, that's kind of what I want. So here, what do we have? Yeah, so basically this works out where the properties table is, and that's kind of all put in this object table. So it starts with, it's at a certain point that's described in the header, so we've already passed the header, that's easy. And then it starts with properties default table. So if there's a property that you're trying to get that doesn't actually exist in the in the object, then it will use this value as the property. And then after that big table is the object tree. So here objects are numbered 1 upward. That's why I've got assert not equal to 0. And it kind of says with object number 0 being used to mean nothing. And I don't know what it should do if it is 0. So I guess having that assert is kind of useful for debugging. And then they are kind of interesting that it didn't draw this, but it drew this. Using that Ladybird browser again. So in this, basically the different versions have basically different length property entries, and one, not property, object entries. One's 9-bit, one 14-bit. This should cover both, so that's where that 9 and that 14 comes from, and this 31 and 63 comes from the 31 and 63. So in this, it's got some attribute flags. We'll deal with that later when we actually need to read the attribute flags. And it's also got like parent, sibling, child. We don't need that for now. What we're after for the put prop is the properties table. So here we basically work out the offset for the properties table, read that word from basically where the properties table is, and that's going to be a pointer to the properties table. So the properties table here, it starts with the short name of the property. So that's kind of handy because at the moment we're just wanting to dump out the string that is the short name. So it starts with a byte, which is the length, and then the following that number of bytes is going to be the Z string. So we get the length, which is a byte, and then we do that Z string dump, which was in here. And so there's kind of two different modes. I'm going ahead of myself. We're going to focus on this when the length is known to start with. Otherwise, there is actually a mode which comes from the, where is it, fundamentals instructions. And this is going to be text to print of unlimited length. And so that one will pass in a length of 0, which means just go nuts. and that one will need to return what the length should be. But for now, we will basically, we actually want how text is encoded up there. Did we click? So we want to do this. So I built up this very basic thing. We can have a mode, so it's going to be kind of like a state machine. We go through and we kind of pass in the Z character that is currently being done, and then we will append to this strings builder and update the mode as applicable. And so the modes that can be are basically which alphabet it's in. So there's three alphabets: A0, A1, A2. So I've got A0, A, and A2, easy peasy. Then there's also one character. There's abbreviations, which, yeah, that might be another one. So what we can do is just add in, what are we doing? Breathe. I'll just do brev. I'll abbreviate abbreviations just because that's too long of a word. And then this one was the one I was going to talk about, the Zali escape, which will be the next byte is used to create a 10-bit SCSI character. And down here it kind of talks about what that SCSI character is. And notably, the anything over 256 is undefined, so we can kind of store it as a U8, and that's kind of fine. And this we probably won't need to deal with at the moment, but if it comes up, we'll deal with it. I'll put in some unimplemented tags. But yeah, to start with, we just need to kind of go through and work out what character we want to print and add it to our string builder. So I think because we're got a string builder, we probably want to do delete the string, and that is going to take it's going to take a Z string, I guess. Z string, and it can take a Z string. And what this is going to do is basically call delete on Z string dot speed, and I think that's it. I'll do that one. Oh, it didn't like that. So I think I need to look up the Odin spec, search for that. Maybe refresh this. Maybe just go to here. All right, it does know how to do it. Packages is what we want. Haven't actually tried this in Ladybird. It's a bit slow, but all right, we're in a core. Builder. It's pretty slow. The thing is, because it's so slow, you don't actually know whether it's working or it's not. It could have crashed, who knows. Build it, destroy it is what we want to do. So that will be string start builder, destroy, easy. Make that one, builder, destroy, and do that. And we also kind of want to have, maybe this will be, didn't want that. Wanted I see what's happening there. Made a change to my key. Classic. So I want that one. Just need to remember where all my keys are. Private equals file. I think I don't like that. And then we're going to have the string process the char. And this is, it's going to need the machine. It probably doesn't at the moment, but it will in the future. So I'll future proof that. For like abbreviations, and I think just abbreviations actually. And we're also going to take in the string, and we can probably pass that as a. Just don't like that. Fine then. Do the next one. Do the next one, then do that, and do one there. I basically made backspace not if I'm in a certain backspace is delete if I'm in a certain layer. Maybe I want to fix that. Do live keyboard edit. So symbols just clear. I like it being that. Remove del. I think I do kind of want the del. So what were these other keys? They were other symbols. Potentially I'll do this is that might not be the best choice, but go on symbols layer. And then I'll also need and download that. Actually, I want to flash this. Select firmware, download this one. All right, get out the trusty. You're gonna need a paper clip. Oh, it's a bit too tangled up. Got a nice little paper clip there. Do the old flash remove. Might speed up things a bit. So this you can kind of see that these are my shift alt hold things, and like when I hold it, it's that. When I tap it, it's the key that you can see. But cool, that works. If we connect, we're in that mode. Easy. Yeah, that is the right key. Cool. So we still need this. So this we can call that the string. Just to point it to it. And we're also going to need a the jar, and that can just be a wait. And this is going to be unimplemented just for now. Right, so to start with, if length is 0, we basically need a loop, and while length is greater than 0, I guess. Length, I think that exists in this language. So every time we need to do that, we're gonna need I think this won't actually work because we're not allowed to edit these parameters. In fact, we can probably do a thing. So postfix what's it wanting up there? See open. Yep, I see. Do this equal width -1 and that. Yeah, so we can't actually change length. Implemented, there's the word we wanted. Right, so I guess we need to do this, and I is less than length, and we do support postfix for no, we don't. I include what's one is there. You're killing me. So this is going to be youth hate as well. Do something like that. Cool. So why did it fail on that? Put prop. Length is 0. That is unusual. But object. I kind of want to do yeah, I'm printing and want to do that's there for X. Do that. And oh yeah. Because my thinking was yeah, so let's oh yeah. Um, maybe just do that. Well, yeah, zero, zero. Do that just so I don't get taken away from the file every time I make. Right. So the properties table is not right. Let's go this way actually, and Z tools. That's one. And info dump. So if we do this, the objects table is O2. O2BO, that is correct. And the objects table is just that plus a bunch. Oh no, that's just, yeah, the properties is wrong. Objects table is right. Offset seems very high. Offset is like crazy high. Maybe I want to see what G2 there. Objects number. That one. Object number is 9C. It's less than 255. I think this for dump we can do objects tree or O. So maybe if we do O long as well, that's in decimal. So well, actually, let's run that again. For 156, it reckons we can go with 156. It does. I don't know why the. One five six dot. Don't know why they didn't search it. Magic. So that's kind of what one. So the properties address it reckons was 0. That's wrong. This offset just seems wrong, and that would kind of make sense if the properties table is wrong. So the offset, I guess this means that I don't have the tables object table. What's the other thing we could do with this object tree? Tree. Nah, that's not really what we want. 6 dot. Right, so this is kind of what we run, and I think this we can also confirm from for if 3A. But it's magic, but one, 5, 6 dot. The dot doesn't really mean anything because really, well, it means everything. So this offset is incorrect. So it's U16. So it should be cool. So object begins with a properties depot. 31 words. So if it's less than or equal to 3, then it's 31 words. And then from 1 upwards, it's 9 bytes. So that's the object number minus 1. And then this plus 8 was, oh, that's not right. We only want plus 7. So find that 8 and replace it with 7. And what's this one? 10, 11, 12. That's right. Cool, that's in the correct place. What do you unreachable there? Because I believe this. Oh, I guess it could be there. But I feel it is the. But yeah, I'll probably just do the unreachable check anyway. Cool. That was awesome for you all. So if we get back here, we're back here. Perfect. So here we want to get a word. So we could probably just call it word, and this will be machine read word. And we're going to take the machine and we're going to pass in address plus plus I. And I believe we need to pass that as a U2. Just right. So here the word is that, and I guess if I equals length, if I is less than, if I is less than what, length minus 1, then I might just do an assert that bit of word of 7. And I guess not that. See if that kind of works. Yeah, so we don't have bit in here. Bit is an instruction, I think. Bit. So I think I want to take that into machine, just because machine has like I've lost it. That's quite annoying. I guess I can get it from this. I should have opened up another window. Alright, grab that. And from that. Um, Me struggling with them. Cool. So now this should work, and hopefully not. Yes. So here we want to get you. Well, no, we want the UH of this. I think there's a way to. In fact, let's try that out, and because it can be kind of useful. I'll talk through what I'm going to do. It could be kind of useful to say the 14th bit of this word, because yeah, otherwise I kind of have to do this UH do word and shift it down by X, which I guess isn't that. And that's basically taking this whole thing, shifting it down by 8, so he'll be sitting in that part, and then check the 7th bit, which will be that 13th bit. Well, it's the 14th bit, but cool. I think I want to do that one there. You sure do have to do very explicit casting of things. Right. It didn't do that assert, which is so I guess here we're going to have 3 words. So the first word is gonna be the whole word shifted down 8, and then shifted down. Well, we can actually just shift down by 10, which will bring this into the lower 5 bytes. So word shifted down by 10. Let's do this and do that, and then and it by 0b 1.5. And I feel like that could maybe be a helper method, but yeah, that's all right. So here we would just do we don't have that because it's the string process C char, and we passed in the machine, and we also passed in the string, which we don't have. We'll probably need pointed to it. And also this Z char. So at the start of here, we probably need to do z string, and that can be a z string, which will get just done as the thing. And actually, we can just go defer, delete z string, z string. Something like that. In the Z string, it kind of had a pointer to a string builder. So I guess, how did we get the string builder built? Where did we go? Init is probably what we want. This is just jumping all over the show. Cool, we're allowed to scroll kind of. Right, this is not working. We'll do it in this. Right, is this what we want? Yeah, this is probably what we want. And we don't really know the thing. We could do like a make, actually, make. Yeah, so I wonder if we can do make, well, these dot sb equals make x6, the pointer to that. Wow, actually, so that just, yeah, we don't really want that. We've already got the builder. No, we don't really. So this is going to be strings dot builder. And I think just like that. Is that what Odin will like? No, this isn't what Odin will like. And it doesn't like that as well. Right, so does this kind of say how we can use, actually not, said overview how builder. All right, string builder is let's type yeah, so string builder is its own thing. That the strings dot and we probably want to just make none, which will return us either a res or an error. I didn't really say it. Yeah, build it, make none. Build your make none. Pass with those things, and this will also pass us an error. I think that is what we want. Except we want, nah, I think we can do something like that. If air do unreachable. It's not really unreachable, but it's like I don't know, something's going on. You've run out of memory. Who cares if you've run out of memory? There's a lot of memory, and this is like it won't use up that much. Otherwise, we'll go to the string. Well, we can actually do something like this. And then it'll be the string, and then we can do something like that, and SB like that, SB something like that. I'm gonna really hold that down. I guess this needs to just be that. Right, now we're down to something. So this, I guess, we know will be U A. Not like that. So I guess we can U H this whole thing. We will delete that and do that thing. Vim surround plugin lets you do that. Cool. Now put this in a weird place. Buff is the string. Cool. So it does it there now. I guess didn't know I had a bunch of numbers there. I guess I could probably do this. $2 and then find that and paste that instead. We put that there and do that. And here we can just do the 3 bits as is. So the second one we'll just want to go down 5. And this one we would just want to go down 0, just to make it a bit more even. And then we just don't need this Z chart. So that's kind of the main loop of this, and we would then probably just want to go Z format dot print, and this Z string had none of this. It didn't really jump to things. Builder, we can just do string string to string a builder. Perfect. Actually, no, we can just go. No, yeah. To spring stuff. Bring it up to spring the string notice be go there. Yes, I did mean that. You don't often have to dereference the pointer in Odin, like it just does it automatically for you when you do the dots. But if you actually need to pass an argument in, which takes an explicit not pointer, then you have to dereference it, which is just that on the other side. That's just how it does. Different formats, different syntax, but syntax is just syntax. All right, so how do we want to do each character? So I guess we need to work out what. I think I just want to do. Well, we can do like a header equals machine header and get the header, and maybe I'll just do an assert header version equals 3 3, that's the one I want. And yeah, like otherwise you have like a lot of different version stuff here. You have like if it's version 1 and 2, then you have like shift lock characters, which we have to probably change in the mode there. And if you're version 1, then you've got like different things. And if you're yeah, I think version 3 and later like just all the same. No, there is like stuff here like version 5 and later have like a different alphabet table. So yeah, I'll just start with this. So I guess we can probably see what things we have. Format dot print line, and maybe we can do f line and do sensor 2x, and we can just pass in that feature, and let's just see what is happening. So the first one is 0. Would that be relevant? So alphabet table printed as a space. I don't think that is correct. So I guess what I would want to do is format dot print f line for x and do this word. And I think because that's kind of surrounding stuff. Actually, I kind of want this to just be what 16b. Yeah, so this doesn't look right. So it would be like 0. The second one would also be 0. No, it will be 1, and then it will be whatever that is. 2, 4, 8, 16. And what's 16? Well, 1. One. What would 1B. Yeah. 1, 2, and 3 are abbreviations. Don't really want to go down that hole. And what was that last one? 16. So that would be yeah. So what do we have? 10, 16. There'll be a J. This is nowhere near magic boat, which is what we're hoping for. Oh, this just isn't right. It's good fun when it's not right. Uh, let's do some cleaning up. I feel like I need to go back to here and what equals zero for x length equals center. Well, this can just be C E and we can do properties lengths. Do something like this. And maybe bring up this again. But this doesn't quite seem right. Property address is not E2, it is 19E2, so we've lost like a byte there. Of and into if properties not equal to 0x, what was it meant to be? It was meant to be 9E2, 19E2, just so we don't lose this page. Right. So that's that. Fixed one issue, made a bit of progress, then found another issue, and I think that's probably it. Getting a bit tired. I'll look at this a bit later, come back to it. But for now, see what happens. Thanks for watching, and I'll see you next time.